Now let's start going through the requirements that we discussed we would do in class today as a replacement for a lecture. We're going to just have this video. And I'll start putting a couple of stuff together, not so much as a replacement of lectures, but mainly as kind of supporting material. So there's a little YouTube channel here. It's all unlisted stuff, so it's easily discoverable if you just Google AJH classes. We'll put this video there, for example. Today. So just get back to where we're at. I want to be kind of as clear as possible here. What's going on, and just make sure everyone fully understands what exactly a requirements analysis is, what exactly a requirements document is. There's a lot more to it than simply just kind of putting a few paragraphs together and bullet pointing the document that we've been working on. And hopefully we'll shed a little bit of light during this video right now. You know, for example, one of the major things about having a set of requirements, obviously, as well as, you know, the customer is clear on what's going on, is that the developer is clear what's going on. And you know, we talked about things like completeness and consistency, and one of the questions that you're actually asked at the end of the sample document here is it precise enough? So I'm going to go through all of these things right now, but please, just be aware that the requirements document and the use cases are very useful right up until the end of the semester. They're going to come in extremely useful, for example, in the testing section. We have here this sort of verifiability section. Can the requirements be checked? And when you're doing that final testing section at the very end of the course, you know, it's a 30% section. And where do you really begin to build your tests? Well, you go back to your use cases and your requirements, and you basically have to test in a formalized way, which we will cover in class. Did your project do what it said you were going to do? And it's not a case of me or somebody else just kind of glancing through it and sort of verifying this for the testing. There's formalized automated tests that can be written. So we're pretty much going to leave the sort of designing stuff for the next few weeks once we get back to class next Friday in labs. And we're going to start working on really the proper design of the class diagrams, making the program, and it's going to be very practical and less fiddling around with diagrams and less drawing use cases and bullet points, and more actually programming. But then when we get to the very, very end of the course and the final weeks after all the coding's been done and kind of debugged, you know, we need to do something called unit testing. And unit testing pretty much goes back to your requirements and says, you know, okay, well, you know, did you deliver what you said you were going to deliver right back here? And we'll run a whole series of tests to verify that. Okay, so like that's a good thing, because it really clears up the options that you want to keep open for changing the requirements. You know, they're inevitably going to be incomplete and inconsistent at some point. And rather than just sort of drastically changing the implementation, you just want to slightly modify your requirements, keep that open. There is a sort of a certain amount of change management that's important. And you certainly don't want to end up in that situation like we talked about before. Do you know this kind of how the customer explained it, what the customer really needed, how the programmers wrote it, and all that kind of business there. Okay, so let's just move on quickly. I'm trying to keep this video as concise as possible. So this is what I went through today in class. I wanted to talk about how it all sort of fits together and where we really should be right now. And where you should be thinking right now is actually user experience. You really need to be thinking in terms of the user experience. Now, UX actually stands for universal design. It's a different thing, kind of, but very related. You know, about creating a user interface and having a sort of consistent experience. These things are not necessarily just for you know, about colors and kind of keeping things as pleasant as possible. It's really to help you, the developer, get the coding right when it comes to time to do those classes, that your user experience is already laid out so specifically and so clearly that there's really no arguments about what variables, what attribute should be in those classes. That variables that should be. And when you're even, there's a section on this particular upload about user interface design. Now, I don't really want to go too much into that. It might confuse you. I wanted to spend more time doing the systems modeling for use cases, but just keep in mind that you don't want to have a system where a user is clicking unnecessarily on stuff. So if they have to find stuff, if you're doing a search system, there should be a good variety of options. There should be search bars, like you can even see in that example. There's a search bar there, and there's options to click on. Very little typing. There should be as little required from the user as possible to get the information that they want. Okay, so here is just a sort of recap of what we did in labs today. And it's the requirements documentation. That's really what we're about today. Now, there's other documentation that's due, not so much today, but certainly you've already done your proposal. And like I said before in class many times and in labs, this answers one question. It says why? Why do this project? So I think everyone's clear on that. All of you have very good ideas and very good project proposals written out. So they're feasible. Their motivation of them is high in terms of the need for them. So that's fine. That's pretty good there. The design answers the question of how are you going to implement all this, and that's we need to think about class diagrams and entity relationship diagrams, activity diagrams, and things like that. And when it comes to that design, so that it can actually be coded very easily by working off that template. And of course, as we mentioned, requirement spec is this big what. So whereas the proposal is why, the requirements is becoming what. The design is really, well, how do we actually implement all of that? So right now, for this upload this week, you don't really need to be thinking about how it's going to be implemented. You just need to be really clear on what it is that's going to be in the end result. So what is that user experience going to look like? Have you kind of laid out the exact, clear, specific, precise details of what that user will actually have to click on? For example, I'm doing this this sort of walkthrough sample of a very basic search where we have to search for something and fill out a profile and purchase something. But you need to be right now today, and for this upload on Sunday, thinking what are the exact things that need to be typed. So for example, is it 4 drop-down list box you need? Is it 6 check boxes, etc.? So let's look at this kind of mind map, I guess, in a little bit more detail in terms of what the flow of your work should look like in this document. Now, as I said before in labs, okay, there's always bits of a document that's like kind of secondary, it's sort of complementary, it's sort of supporting section, like the supporting cast in a movie or something like that. And then there's the main characters. There's the protagonists, the serious kind of sections that are really non-negotiable. They have to be done, and they have to be done well. So in this document that you're doing now, that you've got a template for, the sort of conclusion and the technical requirements, like we'll need a modeling language, we'll need something like PHP, we'll need something like MySQL. Those are the supporting cast. They're not the core elements of this document. The core elements of this document are what we've been doing in labs, which is pretty much the scope systems. And here I've kind of given you a little example where we have a sort of a scope. These are the systems of what's in and what's out. Excuse me. So very basically in this example, you have a searching system. It could be searching for products that are electronic products, for fashion, for shoes, whatever it is that your original proposal specified. I've chosen here that there's 3 core systems. There's the search, profile, purchase. Not going to do reviewing, not going to do returns. That's out. The customer can't come back later and say, oh, where's my review? Where's my returns? But it's not just for the customer. It's you from the get-go, from the very beginning, laying out your full plans for how this is going to materialize, right up as far as testing. Like I say, right up as far as testing and debugging, because that's one of the core sections for it. It's verifiability. Okay, so you can avoid that situation. That's great, but it's really, you want to verify for yourself. It's not just the customer that you kind of have to worry about pleasing all the time. It's you yourself want to make sure that you can verify that the thing is actually doing what you want it to do. It's your system. You're writing it. So in some ways, you're more invested in it than the customer. Okay, so let's see how we can get to that. So basically, these three systems should be marked. I think you should mark them. I mean, at least give them a name, such as the search, the profiling, the purchasing. Some people had the ordering, the adding menus. Some people had the viewing the menus, things like that. And I've just labeled them S1, S2, S3 because it's okay to be like that kind of. This is not, like I said, I used the joke in the class earlier. You're not writing Harry Potter chapters here. This is not a novel you're writing. It's a technical document. So it's okay to put these labels so that, you can find things a lot easier and see how each relates to each other. Okay, so this should have been done by now. I think everyone's got a walkthrough, which is essentially a kind of a narrative for each one of these searches. If you haven't done that by now, be just ruthless. Pick 2, 3 max of your subsystems and get the walkthrough written. It's basically a narrative. It'll probably read like something like the user will search through the the index page and have a lot of options such as search bars and clicking on drop down list boxes and maybe filtering further with some check boxes, to specify maybe the color of the runners or the jeans or the car you want to buy. And that's kind of just a paragraph narrative. Now, let's get back to the main flow. That should be done by now. And then the next section we want to move on to is the specifications. Requirements, basically, often called specifications. And what this does, is, as you can see, is it pretty much repeats it. It looks like it's repeating. Now, it's not actually repeating. It just looks that way. Because what it does is it takes that narrative, which was probably a paragraph, and we go deeper into it. You're taking it like peeling back the layers of an onion. And, if you did that right, and you laid out the walkthrough in 3 or 4 sections that are core sections that you're definitely going to do, as opposed to the sections you're not going to do, this section of specifications should be pretty easy, actually. It should be fairly obvious that you need an S1 spec as well, and you need an S2 specs set as well. And I suppose the way this might look, and if you look at that example that's on Moodle, just take a look at that example. It's there. It's under this week, basically. It's the week of not where you need to upload it. It's up here at this week, just underneath the actual requirements document. It's there. Some sample use cases of a hotel system, and that's got several bullet points for each of the systems. You'll see it's System 1, System 2, System 3, and each one has a whole lot of bullet points. Now, I don't want to open that right now and start confusing you, so let's just go back to this simple system with 3 of them in there. And in the same scenario, you can see, whereas the walkthrough had a narrative for S1 for System 1 search, the specs requirements has a similar description. It's the description we're talking about here of System 1, the search, but it's very, very precise. This has to be precise and it has to be verifiable. So you need to kind of think, well, how many drop-down list boxes will I need? Am I checking the make, the model, the engine size, the body, as in, is it a hatchback or a SUV or whatever the car is, to use that as an example. I might want to filter it further with some check boxes like only show white cars, only show cars that are over less than 10 years old, for example. And if all of that fails, there should be other options, like a search bar where you literally just write it in. Now, these things may or may not get used, but it doesn't really matter that they don't get used in the end. If the user needs it, it needs to be there when they need it. So, for example, this lady clicking on something that looks like a mobile app is not seeming too interested in the search bar, but at some point you may need that. You may eventually just need to just type in a search. So it means that it has to be there. It's got to be coded. It's certainly got to be planned at some stage, and that's what the requirement spec is. So, you'd have one again for the S2 for the profile, and it's a bulleted. It's all the details, all those little kind of specifics that you can imagine in the final project. It shouldn't be really difficult. In some ways, it's actually more difficult for programmers than it is for users, because like the user knows what they want. The person who owns the clothes shop or the electronics store, like he or she will know exactly what they want in the final product. Okay, because they work in that business. So you basically, while it looks like you're repeating yourself, you're not really. You're going into a deeper level. And this section, I can tell you, this is going to become your best friend in the next section, because the specifications, requirements, again, if done right, we can see because we've got 4 drop-down list boxes. Well, we're probably going to need 4 variables at some stage, aren't we? Remember those things in first year and second year, variables, and those variables might need to be clustered up and divided and categorized into classes. All sound familiar? Okay, so this is going to help us immensely in terms of object-oriented programming and design, because that's what we're really doing. We're building objects here. Here's the search structure to make use of the car object. We will have the customer object to make use of the profile object. Okay, the purchase object to make use of a transaction, things like that. A sale object. Okay, now S1, S2, S3. If you're going to do this specs requirement, you will need a use case diagram for each. Now, this is a bit of an odd one because people were asking me about this in classes, and I got the impression that it wasn't fully clear of exactly what a use case is. Just be aware that a use case is a model. Okay, if you're going to, plan a user experience, design a user experience, design anything, it's always good to make up a model of it. Just like you would build up a model of a house. Okay, so if you do open that lecture section here, you'll see there's modeling. It's just an abstraction of reality. Like, there's a little model of a building before you go and build the real things. They are simplifications. They do ignore irrelevant details and only represent relevant stuff, but they come in very useful because they basically contain the entire set of requirements. Okay. And I mean, I'm not going to go into the advantages and disadvantages of it here, but it's considered in software engineering. It's a pretty much a given that you'll make some sort of a model of your system before you kind of code anything. Okay, so you're not going to build a CAD model like you might see in engineering, and you're not going to build a picture that you might see to build a house. So what do you do if you're not going to code it? So you use cases. You use some kind of a case tool, and the case tool of choice that we're using, it's very popular over, let's say, the last probably way over 10 years at this stage, is this unified modeling language, UML, which has access to use cases. And use cases are the elements of UML which explain the user experience. They model the user experience. And these are easy to read, perhaps difficult to write, and perhaps difficult to create. There's a little bit of an art form to it, you might argue. But they are easy to read. If you produce this type of a diagram where the actor, here's the actor, okay? The actor, not the Golden Globe type of actor, just the actors, the characters in the system. The characters involved in any system. This is all model. Even the class diagram is a model. The use case diagrams are just the model which involves actors. okay, and they're useful in the requirements section, okay. Very, very useful, very, very important, because like I say, it's the requirements which will ultimately be tested at the very, very end. Like, you'll be shocked if you do this well, if you do it right, just how important this cast will be in May when you come and you've done all your coding and everything's looking cool and the thing is running and no bugs. And when it comes time to test it, like, if you've got your requirements and your use case models ready to go, that testing will be, planned well in advance, and it'll be fairly straightforward on how you're going to run your automated tests, because you've got the requirements that you want to make sure are actually working. So let's go back to these so-called actors. I mean, actors can be anything. They don't have to necessarily be a human. Generally, it's probably going to be a customer or a user, an administrator. The system itself might be a user. Any of you doing those fitness apps? A lot of people are interested in fitness apps and figuring out this, the keto diet. There's a few, and there's a couple doing gym advice systems. Like, that's going to obviously demand a customer giving a very detailed profile, the profiling system for a gym. That's going to be enormous. You're going to be literally telling the system what you had for breakfast every day, telling it all those kind of things. And what you get back is calculated by the system. So it's kind of the system that gives you the advice back, So actually, these actors don't have to be people. They don't have to be humans. And there's a central database. I mean, generally speaking, I've been kind of veering away from calling the database an actor, not because it's not correct, because it can be confusing. For now, let's just think of the database as being a sort of a box where all of your data will eventually be stored. Because what happens when you put the database as an actor, everyone starts with the database and designs that first, which is kind of, the cart before the horse, as you might say. Okay. So, obviously you've got these kind of, scenarios as well. And the scenarios need to be named, and they can have extensions. So you make appointment, it's a use case, actor makes appointment, you may cancel appointment, and these are just extensions. So just one thing to be really, really clear of, and I saw a lot of people doing this in the lab this week, is everybody knows pretty much how to read a use case diagram. I think at this stage I was kind of impressed by everyone's ability to read the use cases that I showed you. And when you jump into it, there's a tendency to do the sort of overall use case. So you have a use case that has a search, a search bubble and a profile bubble and a purchase bubble, and think you're finished. Well, when you keep track of this kind of flow, you won't fall into that trap. So if we have these systems in the scope laid out, system 1, search, system 2, profile, we need obviously a walkthrough for each of those. We need a requirement spec for each of those. Okay? Again, look at the document, look at the sample document that's given down here of the banking system there. Sorry, the hotel booking system, I should say, not the banking system at all. It's a use case of a hotel booking system, which tells you exactly number of rooms, number of people coming, all that kind of stuff. Have a look at that, okay? Well, if you've got that requirements for all three, you'll need a use case model for all three. So in this situation, what would be expected for a good requirements for the what would be a decent narrative walkthrough for those three systems, a good, very, very detailed requirement spec for each of those systems. So you have 3 requirement specs, and that's going to be very useful in building up the types of classes you want and how we're going to really put the data into memory. But you really will need to have the use case diagrams for each. Now, most of you seem to have about 3 to 4 major systems that you're going to do, so that would mean you'd have to do 3 to 4 use case diagrams for each. That's pretty much the way this would operate to create that model. I mean, that's literally the model that you're creating for the user experience. And when it comes to testing time, we will look at that model again. It won't change that much. There's a little bit of change that's required. Obviously, there's change management, If you mark the system down, see that says ticket system and purchase ticket. So in my example here, this is going to be the search system to create the search. And maybe you use the search bar. You drop down a few menus. Possibly you can't get it from there. You use the search bar and then you click go to actually do your search. You might have fill in the profile. That could be something simple as email address and username for logging into Twitter or something. It could be very complicated. It could be if you're trying to do any of these nutrition systems, gym systems, political affiliation systems, even a security. If you're going to add security to that gets huge because you've got things like what do you call those kind of questions you might get asked on Facebook? These security questions, and they ask you where were you, where did your first cat, what was the name of your first cat, and where did your parents meet, and all these kind of strange, intrusive sounding questions designed such that only you could answer them. Okay, so just in summary there then, so just where we're getting you at, the purpose of the requirements is the what. What is it that the user experience is going to look like? That's the only really serious goal here. And that's a good place to start, because you don't want to start with something like a database, because that's not even programmer centered. That is not programmer centered at all. That's like kind of like administrator centered. Okay, that's like allowing, the bean counters at the end of the day to dictate exactly how your system is going to work. Okay, like it's like allowing the person who keeps the records to dictate exactly what your app is going to look like. That wouldn't happen in the real world. It's easy to envisage that when you think of like a manual, a real physical person keeping records. Could God forbid, could you imagine like a situation where even in a school, for example, where the government dictates exactly what should be learned in school and everyone learns it this way because it fits the database a little bit better, so clearly that's not the best way to center something. Centering it on the user experience ensures everything kind of is clear for giving everyone what they want. It'll not only help you give the user what they want, it actually helps you make your design easier. It'll help you do this requirement spec will really help you do your design a lot better when it comes to making those classes and getting those calculations of the system done. And the real kind of icing on the cake for doing these use cases well is, by the time you've forgotten about them and you've gone through the section on designing the draft and figured out how to draft up a mock-up using the agile technique. We're going to start agile next week, and literally you have to have a little piece of the program built every single week using these increments. 4 weeks passes before it's March. And you do your demo and you're worried about demoing your program and getting all that code working. And finally, this testing, like I say, the testing, we will go back to our use cases once again, because it makes sense. What are you going to test? You need to say, does the program do what it said it was going to do? And there's actually especially using PHP, there's automated unit tests that we can build, which test each of your classes. So that works in a kind of a similar way. We need an automated test for each use case. Okay, when it's all built, we need to go back and say, okay, well, we need a unit test for each use case, a unit test for each class. Okay, so if you've done it right and you've done it to some satisfactory level, happy days. You'll really reap the rewards of it then, and it'll make it a lot easier for you. You'll feel a lot confident about approaching that big kind of hand in. That's a big submission, that 30% there. Okay, so where are we going now with this? Let me just look at my own notes to see what I wanted to cover. So requirements docs, the what, that's due this week. Scope walkthrough done last week. Requirements, specifications, and models done this week in labs. And like I say, I think there's 5 out of 6 groups. I'll go easy on group 5 because they have their lab effectively today. And do email me any queries you may have if you're in group 5 and you're worried about approachability. I'm absolutely happy to read through any of your requirement spec and give you feedback straight away. I am on email all day, so I can respond to you. But this essentially is our first stage of kind of the design. So we're going to delve into the class diagrams next week. Okay, so when we're going to look the point of material that we look at to get those class diagrams built will be the user requirements, the specifications. Okay, so this kind of boundaries, the relationships between the different use cases. I think most people understand how to do the difference between includes and extends. Extends may or may not happen. You may or may not use the search bar. Okay, includes is if you need to then fill out a profile to buy something, well, that's a definite include. You must have a profile to buy something. Okay, use case relationships, they can get kind of big, but I think what you should probably do is not start off with something like this large scale system. Just do them small. We can always come back to it. Just do the few systems first, and we can make a larger one later to fit the design. Okay. So there's a vending machine. Here's the vending machine use case. Now, I did say in labs that there's none in the sample. If you look on your Moodle and you see that there was a sample for a vending machine, there's a sample document with scopes and walkthroughs, and it doesn't seem to be a use case with it. Okay, the use case seems to be missing from this sample. Anyone who's in labs this week and we looked at it will know that. Well, there it is. It's actually here. Here's the vending machine example. It's in here in the lecture. The lecture, that's two notches up. This one here. Okay, so there's the example. Here's the actual PowerPoint, and that's where the use case diagram is. Okay, so we can see, it's a sort of a user UI developed as well there, and it's concentration on the external behavior of each of those activities. Now, we don't need to do the activity diagram. It's like it's basically like a state diagram. How the actual activity kind of plays out as it's executed, and how essentially classes are not static. These variables are not static. The variables are going to change. That's what an activity diagram is. An activity diagram. If we end up making a class to model this car with make, model, engine, body, to model the profile with username, password, whatever, user ID, things like that. Those variables that end up in the class diagram are not static. They change constantly. As you log in, your status is something. As you log out, it's another thing. As your search changes, your make, model, engine size is going to change continuously as you're doing your searches. And that's what an activity diagram pretty much indicates. So you can see in the sample, you're inserting your coins, you're getting a cost, you're getting change, the money being transferred, the money being kind of handled at any point is always different. So just like that's if you think about memory and the values that go inside variables, even in first year, it's always changing. You don't just say make a cinema ticket with the price and the number of people going, and it's always the same. It's called variable for a reason. Variables constantly change. The values constantly vary. Classes are built up pretty much like variables. Are objects in an object-oriented program such as Java or PHP will act like variables and constantly change. Now, we don't need to do that for this one. This is not something that's part of this upload this week, but I'm just going through it because I don't want to miss this week's lecture. I still want you to do the lecture by this video this week, and essentially for every use case we'll need an activity diagram. Okay, so when it comes to the design, we will build up a class diagram, which I think everyone understands. We'll build up an activity diagram for each of those classes, and that should give us a good indication then of how to do the database. Okay, so activity diagram, and that's pretty much it. I don't necessarily think we need to go beyond activity diagrams. If you can do use cases, class diagram, if you can do a use case first, a class diagram, and an activity diagram to sort of understand the values within those classes constantly changing because they are variables and They're called varied for a reason. They vary, and there's a lot of activity to make those changes. If you can do that, use case, class diagram, activity, the entity relationship diagram should naturally flow from that, and that's about as much as you really need. I mean, it's a minimum. There is other things you can do with the design, but that should set you in a good foundation. Just a quick word about user interface design now. Okay, so everyone's been kind of, in labs, we've really heavily focused on these scope specs with the walkthroughs and the models. But there is a section after the user and after the use case diagrams called the graphical user interface. Now, one of the worst things you can do for this is start coding it up in HTML and actually build the user interface and sort of, say, I'm just building it because this is how it's going to be designed anyway. Be careful doing that because it leaves no room for changes. Could you imagine if we want to suddenly take away one of our drop-down list boxes or add 2 or 3 more drop-down list boxes and they don't exist on your mock-up of your user interface? So just be careful. Let's just use those sort of wireframes and keep it very. Don't commit to anything too seriously for your user interface in this instance of things. So obviously, I think in all of our programs that I've seen in labs, they'll all will need a user interface. Very, very important. It keeps not just the user's perception. That's a bit of a misleading term there. Perception can indicate the look of it, but the feel of it. When you're using it and it feels like it's running in a certain way, the user experience should have things as it should first of all find what the user wants, carry out the thing that the user wants, whether it be a search or a purchase or a profile, but it should do it in an efficient manner. Do you know what I mean? It's only as good or bad as its user interface. That's really why we're talking about this stuff so much. So there's a few general kind of elements of a user interface. Obviously consistency, but for most part for 3 systems it should be easy to stay consistent. If you've got an S1, S2, S3, color schemes, fonts, widgets. But I guess really the thing is the sequence should match the user's business practice. So that's why I keep asking people if you do you know how these things work? Do you understand what it's like to work in a cinema or a gym if you're doing a gym system? Because you need to create that physical experience. If you're doing an automated gym system, you need to create the system that's as close as possible to a human coach or gym instructor working with you. Okay, color sparingly. I don't need to say that. Generally, computing students don't have too much trouble with that. But, one of the things you want to really be careful of is that there's not too much for the user to do. The user should be able to recover from mistakes very easily and should get what they want quickly. So not only should there be the minimal number of clicks, let's say, to get what you want, the minimal number of typing, avoid the user having to type anything if possible. It should be possible to recover from mistakes. And a good way to do that is have cancel buttons and go buttons at every juncture. For example, here's the search, go, but you may decide I don't actually want to do the search anymore. I want to cancel it and go back and re-look for a different type of a car. Okay, now I chose this one for a reason because I've actually got this program completely done down to the coding and down to the testing of car make and model in PHP. Okay, and in some ways I've kept it sort of simple looking. When I show students, they think, oh, that's a very boring looking user interface, but the user interface I've done is as quick as possible. It's the quickest way that I can design to get the information to the customer as quickly as possible. And it leaves the option to be scalable, to add new things. If I suddenly want to add like electric cars, which I haven't got on the system, it's still scalable to put in those type of things. I think I have something for hybrids, but not fully electric cars, for example. Okay, so just keep that one in mind. That whole slide, recover from mistakes and use the minimal number of work and clicks possible. Like, would you honestly want to, spend all day clicking to get to the information you need on your phone? No, I mean you can tell all those good phone apps are developed that it's just 2 or 3 clicks and you've got it. You don't even have to type half of it. Even if you did have to type it, predictive text will click in. Okay, so there's some general principles there, familiarity, consistency, but really this idea of minimal surprise. Minimal work and minimal recovery. Okay, it's hard to do than it might look, but you know, when you're dealing with 4 or 5 drop down lists. Okay, so coming to the point where I said I would stop at 45 minutes, and just to summarize and all of that, then, so we are obviously going through the requirement spec. It's user experience that we're dealing with, but the most important things, like I say anyway, in the lectures and the labs the last few weeks, is to get that pipeline. Okay, so the 3 systems, 3 or 4 systems, whatever it is. If you've got 2 systems, that's okay too. That's okay as well. 3 walkthroughs, 3 requirement specs, 3 models. The reason you're doing this is because it'll ultimately be the source material we use for the design to create the classes. It's very specific. It's not just a simple narrative like the walkthrough. We need to be really precise in this. And the reason you need to be precise is because it's going to be our kind of map to build up the class diagrams and the variables, etc. We'll also not just ensure the customer gets what they want and that everyone is in sync with each other. It also will be a tool to build our test cases later on, and eventually ultimately our activity diagrams in the next section. Okay, so that's pretty much it. Thanks for listening. If you got through all of that, where are we?